All right, gang, we're going to be working on worksheet 4.1B. We're going to be doing triangles, and we'll be looking at their sides and angles. This first question that we have, we will be graphing it and then classifying it. That's naming it according to the sides that we have. Directions say graph the triangle and then use the distance formula to classify the triangle by its sides. It gives you the distance formula there. We will determine if it's scalene, isosceles, or equilateral. Remember, scalene means that it has no equal sides, isosceles has 2 equal sides, and equilateral has 3 equal sides. Question number 1. Point A is at -3, -3. So we're going to go backwards 3 and then down 3. Put an A there. Then B is at -3, 3. So we will go backwards 3 and up 3. There's B. And C is at 4, 3. So we will go to the right 4 and up 3. Draw that triangle that we have. One nice thing about this triangle is that we notice it runs right along the grid lines for 2 of the sides. So to find to find AB, we can count 1, 2, 3, 4, 5, 6 spaces. Fill that in over here. AB has 6 spaces. BC, we can count those spaces. 1, 2, 3, 4, 5, 6, 7 spaces. So BC has 7 spaces. And then we just want to use the distance formula for AC to find out if it is isosceles or not. Remember, the distance formula squares the difference of the x's, which we have that distance is right up here at 7. So we could take 7 and square it. And then the distance of the y's, and that is actually this number right here, y2 minus y1. And so we can put that right here and then take the square root of that. We have 49 plus 36, which gives us a total of 85. And the square root of 85, although I don't know the decimal value of it, it's definitely not 7 and it's definitely not 6. So we know that all the sides are different. So to classify this triangle, we could call it scalene. And if you remember back to algebra, we actually know that it is a right scalene because those 2 sides are perpendicular to each other. The next section we just want to talk about real quick because it does ask you to explain why, and I want to make sure that you understand what that means. Question number 3, classify the triangle by its sides. So we will be answering either equilateral, isosceles, or scalene, and then we will explain using the definition from our notes for each of those things. If we look at question number 3, we see that all of the numbers are the same. That makes it an equilateral triangle. And simply to explain that, we just say that it has 3 equal sides. That is the definition. On the other side, if we look at question 7, now they're asking us about the angles. We have to classify the triangle by its angles: acute, right, equiangular, or obtuse. And then explain our answer. If we look at question number 7, we have the 30-degree angle, we have the 60-degree angle, but we definitely have a 90-degree angle right here. That makes it a right triangle. Why? It has 1 right angle. Explain why is simply just that. The next chunk of problems ask us to do a drawing according to the description of the triangle. Sketch triangles that satisfy the requirements described. Be sure to include proper markings or numbers. Right, not possible if the triangle cannot be drawn. So we're including tick marks, maybe degree numbers, or a little box in the corner or something, so that we know that it is exactly the triangle described. If we look at question number 11, it asks for a scalene right triangle. A scalene means that it has no equal sides A right triangle has a 90-degree angle, so we have to draw that. So first thing we do is get our 90 degrees in there. Then from there, probably the easiest thing to do would be to include tick marks. 1 tick mark, 2 tick marks, and 3 tick marks. As long as they are all marked different, then we assume they are different, regardless of the drawing that you made. If we look at question 15, it asks for a right equilateral triangle. And I know that a right triangle has a 90-degree angle, and I know an equilateral triangle has 3 equal sides. So you need to think to yourself, is it possible to draw a 90-degree angle with 3 equal sides? And one thing we know is if we have a right angle, this side right here must be the longest, opposite the 90 degrees, longest in the triangle. And you can't have one longest side and 3 equal sides. So this one is not possible. You cannot draw a right equilateral triangle. In fact, an equilateral triangle would have 3 60-degree angles, none of them being 90. In this next chunk of problems, you will be finding the value of x or y. You do not need to describe what you're doing. You're just finding the value of x or y. The main thing that you're going to be looking for is if the angles are inside or outside the triangle. And I do have an example of each of those here. For question number 19, I noticed that all of these angles are inside the triangle, and then that tells me that they must all add up to 180 degrees. The sum of all triangles is always 180. So we add those angles together. X plus 35 plus 90. Don't forget about this guy right here, even though there's not a number. Then from there you add those together. So we have x plus 125 equals 180. Take out the 125. And we get 55 degrees for that angle. For question number 20, we notice that these angles have this exterior angle out here, and the exterior angle theorem said that that exterior angle is equal to the sum of the measure of the 2 remote interior angles. That means we add these 2 guys together and it will equal that outside angle. So we simply just need to do 42 plus 20. So y is equal to 62 degrees. Again, looking these over, you have 1 more outside angle and 3 more inside angles. These next 2 problems can look a little overwhelming because there's lots of parts just to one problem. But if you break it down and do 1 angle at a time, fill it in as you find it, it turns out to be not quite as scary as it looks. So 25 and 26, find the measure of the number of angles and explain how you found them. Important to understand that you don't necessarily always do them in the order that they're listed. Look for the things that you know. The one thing that I noticed right here is that we have this x. We have angle 2 and angle 30 are vertical angles to each other. So that probably would be my first angle I would fill in, and I would say angle 2 is equal to 30 degrees because vertical angles are always equal. Then if I look at it, I notice that I have 2 separate triangles. I have the triangle on the right, and in that triangle we have 2 angles. We have the 30 and we have the 90, and we don't have this angle up here. Knowing that all of those angles have to equal 180 degrees, I do a little calculation. 90 plus 30 equals 120. 180 minus 120, 60 degrees. Angle 1 is 60 degrees because there are 180 degrees in a triangle. And then when I look at the other side, I actually notice the same thing. I have 2 angles. I have the 70 and the 30, and I know 30 plus 70 is equal to 100, so angle 3 has to be 80 degrees, again, because there are 180 degrees in a triangle. Like the last problem, you're going to be doing a little bit bigger problem. I'm not going to do the whole problem for you, but what I want you to notice is that you have, again, vertical angles. These two angles point at each other, 2 and 3 vertical angles. Once you find one, you will know the other. The other thing that you want to remember is that you have a linear pair. The 58 and the angle 3 are next to each other on a straight line. And same with angle 2 and 58. They are also next to each other on a straight line. So no matter how you do it, you will get the same answer. And then again, you have 180 degrees in a triangle, or you could use the exterior angle theorem. Lots of things, lots of options for you to try on that one. Be brave and just try to at least get one of the numbers. This next part, we have to find the values of x, y, and z. We need to go all the way back to vertical angles, linear pair, parallel lines, triangle properties. We're going to use everything that we know. I thought I would give number 37 a try. A couple of things. One thing I noticed that we have not talked about in a while are these parallel lines. Remember, if you have lines that are parallel, you have certain kinds of angles that are formed. And if I have those parallel lines right there, cut by this transversal, do you see on the inside that we have this 118 and this angle Z right here? And if you look closely, there's our C. That makes those alternate interior angles. So I know 118 plus angle Z has to equal 180 degrees. So subtracting 118 from both sides, I get 62 degrees for that. If I fill that in, that will help me with some of my other numbers. If I have 62 on this side, I know that x will be a linear pair to that. And so I know that x plus 62 also has to equal 180 degrees. So x equals 118. And then I noticed, oh yeah, that was back the same as that one. And if I look closer, those two are actually corresponding, so it makes sense that those are both 118 degrees. And then the last thing that I notice is that the x is an exterior angle. Sorry about that. X is an exterior angle to that triangle, so I know that the 22 plus the y have to equal 118 degrees. So if I subtract out my 22, I get the y value to be 96. Three numbers right there. This last chunk down here is about this big diagram, and I'm not going to go through the whole thing with you, but I want to remind you of a few things before you get started. I want to remind you, remember that there are always 180 degrees in any triangle, so if you can outline any shape and you have two of the three angles, you can always find the third angle. And then from there, don't forget about linear pairs, two angles that are next to each other, and don't forget about vertical angles, two angles that are across from each other. So once you find one number, fill it in on the diagram, and that will help you find more numbers. Good luck. See you in class tomorrow.